It is often necessary to convert a given result from one system of units to another. In chemistry, the best way to do this is by a method called dimensional analysis or factor label method. Dimensional analysis uses conversion factors to convert from one unit to another. A conversion factor is a fractional relationship based on an equivalent statement. An example of an equivalent statement is 1 inch equals 2.54 centimeters. To make this equivalent statement into a fractional relationship, you would take 1 inch over 2.54 centimeters, or you could take 2.54 centimeters over 1 inch. In chemistry, the unit is just as important as the number in any measurement. So when wanting to convert from one unit to another, the first thing we do is read the problem and identify the given and the find. In this example, how many seconds are in one day? My given is 1 day, and my find is how many seconds. So I'm going to think about any equivalent statements I might already know to help me solve this conversion. The first thing I know is that 1 day contains 24 hours, and that 1 hour has 60 minutes, and that 1 minute has 60 seconds. So I'm going to have a solution map that will convert from day to hour, from hour to minute, and then minute to second. Now let's use our solution map and equivalent statements to get our numerical setup. To begin with, we put our given over 1 for our initial fraction. Now our first conversion is from day to hour, so we'll use the equivalent statement that 1 day equals 24 hours. The key to dimensional analysis is to get the units to cancel out. And to do this, we need to have 1 day in our denominator of our second fraction so that it will cancel with the numerator in the first fraction. So I must use 24 hours over 1 day. Day cancels with day, and you're left with hour. Now I have to convert hour to minutes. I know that 1 hour has 60 minutes, and that in order to convert from hour to minutes, my hour needs to cancel out in both the second and the third fraction. So that I must use 60 minutes over 1 hour, so that hour cancels with hour and you're left with minute. Now I'm going to convert from minute to second, and the equivalent statement that I know is that 1 minute has 60 seconds. For the minute to cancel out, I'm going to put 60 seconds over 1 minute so that minute cancels with minute and you're left with seconds. Now that I have the correct unit, I'm going to do the mathematical calculation by multiplying all the numerators and then dividing by the denominators to get 86,400 seconds. Sometimes in chemistry you are required to convert more than one unit in a single problem. For example, if you are going 50 miles per hour, how many feet per second are you traveling? Our solution map needs to convert miles to feet as well as converting from hours to minutes to seconds. When converting two units, you can start with the solution map of miles to feet, or you can start with the solution map hours to minutes to second. I've chosen to start with miles to feet. So in my given, I'm going to set up 50 miles over 1 hour, which stands for 50 miles per hour. I'm going to convert miles to feet by using the equivalent statement. 1 mile equals 5,280 feet. Miles will be in my denominator so that it will cancel with miles in the numerator of the first factor. So 5,280 feet over 1 mile. 1 mile cancels with mile. That leaves me with the unit feet per hour. I have the feet part. Now I need to convert the hour part. So my next factor will start with converting hour to minute using the equivalent statement. 1 hour equals 60 minutes. Now this time the hour is in the denominator of the first factor. So for it to cancel out, I have to have hour in the numerator of my third factor. So I'm going to use 1 hour over 60 minutes. That way hour will cancel with hour. Now my unit is feet per minute. What I'll have to do is use the equivalent statement. 1 minute equals 60 seconds. Now minute in the denominator of the third factor needs to cancel with minute in the fourth factor. So in the fourth factor I have to have minute in the numerator. So it's going to be 1 minute over 60 seconds. Minute cancels with minute, so that leaves me with the unit feet per second. And that was the unit I was asked to find. Once I have the unit, now I can do the math. Multiply all the numerators, divide by all the denominators, and I'll end up with an answer of 73.3 feet per second.